This Week in Radio Tech, episode 277, is brought to you by Lavo and the Crystal Clear Virtual Radio Console. Crystal Clear is the console with a multi-touch touchscreen interface. By the Telos Zip 1 IP audio codec. It's the best IP way to hear from there. And by the Axia IQ AOIP audio console. From 8 to 24 faders, IQ is the standalone IP audio console that networks. Cell towers are everywhere, and they're still building more. But trouble occurs when they're too close to existing AM tower sites. Well, that's where Lawrence Behr of LBA Group comes in, helping cell carriers and AM towers live together peacefully. And sometimes they even cohabitate. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host, and glad to be here. This is episode number 277 of This Week in Radio Tech. So we've been doing this a while. This is the show where we cover, as we say, everything from the microphone to the light bulb at the top of the tower. And today we're covering a lot more stuff out at the tower site. So stay tuned for that. Our guest is Lawrence Behr. He is a world-renowned engineer and builder of business to help protect transmitter sites and people. We'll get to Lawrence in just a few minutes. First of all, let's bring in our regular co-host from New York City, the best-dressed engineer in radio. It's Chris Tobin. Hey, Chris, welcome in.
Well, hello, Kirk. I'm doing well. All is nice. Sun is setting here in the city, and it's getting cool. It's that time of year again. But I have my pumpkin coffee with a spritz of Redbreast whiskey, and I'm good.
Oh, man. And I've got a glass of water. So, I guess I'll be the designated driver today.
Just for those who don't think it's true, I do have it here. It's the bottle.
Oh, there you go.
It's important to show proof. It's credibility. Here we go. It goes right in the camera. There you have it.
Is that the one I sent you, or did you have to get that on your own?
No, it's the one you sent me. I've been nursing it very well.
Nursing it right along there, aren't you? That was a couple Christmases ago, wasn't it?
Yes, it gets better with age.
Hey, real quickly, our show is brought to you by the folks at Lavo and the Crystal Clear console. It's also brought to you by the folks at Telos and the Zip 1. And also it's brought to you by Axia and the IQ audio console. We'll hear about those in a few minutes. Let's go ahead and run out to Greenville, North Carolina, which is the world headquarters for the LBA Group, Lawrence Behr and Associates. And Lawrence Behr, welcome in, Lawrence. Glad you're here.
Hey, how are you, Kirk and Chris? Good to be with you guys this evening as the sun sets over beautiful eastern North Carolina.
Did you guys get any of that massive rain that we got in Charleston? I was there. And they got in Columbia.
Well, yes, we did, but we didn't get nearly as much as the guys down in Charleston did. And being down here in the coast, we got more tide than anything else.
Ah, okay. Yeah, I forgot you're near the coast. Okay, so yeah, we had a lot of tide, and I was in Charleston, South Carolina over the weekend when it was all happening. And the police were stopping people coming on to Isle of Palms, where I was at, and making sure, do you live here? Because if you don't need to be here.
Yeah, I have a stepson and his family who live in Charleston, and I was getting fairly regular reports from there. He's a surveyor, and as a consequence, his house is far above flood levels. He made sure of that.
Yeah, that's a good idea. That's a great idea. Hey, so Lawrence Behr is on the show, and we're going to give you just a tad of history about Lawrence in just a few minutes. We're going to be talking about lightning protection, RF grounding, detuning of towers and other structures, AM co-location. And hey, if you engineer for or own an AM radio station, you might be looking at some good alternative income here if you listen to what Lawrence has to tell you about how to create income that's not advertising based. I'm going to pay special attention myself. And also some interesting things about portable AM systems. I'm eager to hear about that. So that's coming up on This Week in Radio Tech in the next hour. Our show is brought to you in part by my friends and the folks at Lavo, L-A-W-O. It's a German company that makes audio consoles. Now, if you've ever been in a television truck or been in one of these big venues like an opera house or something like that, you may have seen a Lavo console. Well, they also make consoles for smaller applications like radio stations, and they have in fact a line of consoles called the Crystal line. Well, the Crystal Clear console is the console that they'd like me to tell you about. It's based on the Crystal architecture, so it's a one rack unit box that fits into a rack. The audio inputs and outputs, all your local ones, are there on the back of that slick little one rack unit box. And inside that box are all the electronics to do the mixing, the DSP, the mic processing, to provide backfeeds, to do EQ on microphones and so forth. That's all built in. And if you need inputs and outputs that are not local, but rather on a network, audio over IP, well, you can bring in Ravenna networking, or Ravenna includes compatibility with AES 67, the new international standard for audio over IP networking. So there's a network jack on there that certainly talks Ravenna and AES 67. Well, the clear part of the console, so I told you about the crystal part. That's the rack, that's the hardware box, right? The clear part is the control surface. It's not a traditional audio console. Rather, it's an application that runs on a multi-touch touchscreen computer with a multi-touch touchscreen monitor. So you can touch several faders at once. I think it's a 10-touch touchscreen. So it's actually really convenient and easy to use. And the buttons, they've redesigned, console faders and buttons to be just right for your fingertip to touch. Just a quick glance or just a reach above or below the fader that you're working on, and you've touched the right button, whether it be an on-off button or an options button or maybe a mute button or a button to pick up a different scene for the console. You can change all the faders if you want to, or just change a couple of them if you need to. So those are all built into this touchscreen monitor application. And the cool thing about that is, let's say that you need to operate the console from another office. Maybe you've got a flood in your area and your studios are on the first floor. I was at a station just yesterday where all the studios are on the first floor, and then engineering and the business offices are on the 7th floor. Well, if you had to evacuate and go to the 7th floor, you can certainly do that. Just put it on the same network, and you're talking again to the DSP mix engine and all the audio I/O. So the Crystal Clear console has all the features you'd expect from a traditional console. It's got a couple of program buses, a separate record bus. It does mix minus for every single input. It's just all these standard features that you would come to know and love about any electronic software-defined console. And speaking of software-defined, when you touch an options button on the Crystal Clear console, it only shows you the options that are applicable to what you're doing now. So if you punch up a mic options button, you can change the behavior of the back feed, or change the EQ, or change the gain structure of the mic preamp. Just things that have to do with the button that you're pushing. Check it out if you would. Go to Lawo, that's LAWO.com, and look for the radio consoles and look for the Crystal Clear console. On that webpage, you're going to find a new updated video where Mike Dosh, who's the virtual radio projects director, he's describing the Crystal Clear console. And so check it out there. Watch the little video with Mike Dosh, and you're going to like it. If this idea is of interest to you, well, the Crystal Clear console is right up your alley. Thanks, Lawo, for sponsoring This Week in Radio Tech. All right, here we are with Chris Tobin, who is an RF engineer himself, and Lawrence Behr, who, he wrote the book on a lot of stuff. Lawrence, we were talking earlier today. I'd like to jump right into talking about the subject of our first video, and that is detuning of towers. Now, Lawrence, engineers spend all their time tuning towers, and you want to detune them. Tell me about that.
Yeah, I'm kind of a contrarian, I mean, everyone wants to tune them. What the hell? Let's detune one or two just for the fun of it. But in all seriousness, it's a growing problem for AMs who are concerned about their pattern and about the interaction with cellular towers, because cellular towers are sprouting up in huge numbers. There are hundreds of thousands of them in the U.S. So inevitably, they begin to fall near AM towers, and not surprisingly, the FCC has a rule for that. And that rule specifies the conditions under which a cellular operator must make these towers invisible, because really that's all detuning does, is it makes the towers invisible.
I should take a second and just point. We have a few viewers and listeners who may not be familiar with this concept. With FM television broadcasting, with mobile phones, the tower is there to hold the antennas up in the air, up high. But with AM, the tower is the antenna, and
exactly.
the entire length of the tower is is involved with the radiation of the AM signal. And because the AM signal, and folks may have noticed, look, you drive through a metal bridge and your AM reception gets very bad for that time. Or if you go inside a building that has a metal, inner structure, your AM reception gets bad. Well, if you put up a tall grounded tower, and most every tower is going to be grounded unless it's a hot AM tower, it's going to act like a tuning fork. It's going to react with the strong radio waves that are in the air, and it's going to re-radiate and change the pattern of the AM tower. And so this is, the FCC gives some remedy for this. And well, would you like to watch this video and we can tell how a
Yeah,
tower?
let me just make clear that the cellular signals have nothing to do with it. It's purely the mechanical structure of the supporting tower that is a problem. Yeah, and I think you'll see that in the video.
Well, let's go ahead and watch the first video about is this cell tower detuned?
On cell towers, it's important to be able to recognize those that are AM detuned. U.S. law requires towers near AM broadcast stations to be detuned to avoid influencing AM radio signal patterns. The chart here shows some of the regulatory considerations. You will find different styles of detuning on each cell tower type. This is a typical self-standing monopole equipped with an LBA detunipole detuning system. Note the tuning box, support beams, insulators, and vertical wires. On any detuned tower, all tower fixtures must be mounted clear and kept clear of the detuning components. Self-supporting towers have detuning boxes mounted on one or more legs or in the tower base center. One vertical wire usually runs up each leg with insulators every 75 feet or so. Here, the LBA detunipole box is mounted on one leg. Guide towers typically have 3 vertical wires and a tuning box mounted at the base. LBA detuning systems are durable. This U.S. cellular system has been in use for over 20 years. If you encounter a tower and need assistance in identifying its detuning status, call us at 252-757-0279. The service is free. Check out www.lbagroup.com for much more on AM detuning.
So we want these structures, these vertical structures that are holding cell antennas, to look invisible. And again, tell me why the AM and the FCC, why the AM owner and the FCC want them to look invisible.
Well, the major reason is that the re-radiation from the cell tower combines with the radiated pattern from the AM station, and it can cause the pattern to sort of poke out in undesired places and pull in other places. With a directional array, particularly where nulls are important to protect other stations, to have those nulls corrupted creates interference to the other stations. And in some situations where these are close to the close to the AM tower, the effects can even be substantial enough to alter the desired coverage of the station and result in dead spots and so forth that commercially are a real problem.
Now, I always associated detuning cell towers with close proximity to directional AM stations, where indeed if you had a re-radiator somewhere, it could ruin the null protection that the station is providing to some other distant radio station, and it would actually, create some field in that direction that wouldn't be legal. And so your monitor points for your AM station could go well out of whack. So we know that it can mess up a directional station. What about non-directionals? Is it important for them too to have detuned cell towers that could cause a problem?
Yeah, absolutely, Kirk. Just an example is that our field people completed work on a system only yesterday that is up in Virginia. A 10,000 watt station is nearby to a 500-foot multi-use tower. And when it was not detuned, the station was unable to make full power, non-directional. They're a non-directional station. And before our guys were called in to correct the problems, there had been a number of people who had attempted, and for 3 years there's been a battle going on between the station owner and the adjacent tower management company over the station operating at reduced power. Today is the first day they've been able to operate at full power in 3 years. So it is very important.
Now, help me understand, why were they operating at reduced power? Was there some mutual coupling with that cell tower, or was it throwing their non-directional pattern beyond some kind of limits?
Yes, it was mutual coupling. It was affecting the impedance of the AM tower. And
okay.
Worse, it was doing it intermittently. There were problems on the tower with loose coax bonding and other things. One of the things that we did when we went in there was have them strip all of the old coax off the tower, go through it top to bottom, rebonding everything. And it was as much a matter of making it stable. Had it been stable, the station perhaps could have operated, because it's not important what your tower impedance is within reason. But it also, with that degree of coupling, obviously had a large effect on its supposedly non-directional pattern.
So, in the last 20 years, I myself had been involved a bit with detuning cell towers. And while I was doing some of that work, and one time I did some work for your company out in the field, I went
You
and took
did?
I took AM field readings to establish. I forget if we were establishing the AM pattern before the tower went up, or if the tower had already gone up and we had to, show, okay, here's what it's doing now compared to here's what the pattern should have been doing. I know sometimes you don't get a call until after the cell tower has gone up and is causing a problem.
Yeah, that's
Maybe you could walk us through that procedure. What's the ideal situation versus what typically happens with regard to new tower construction near an AM facility?
well. I think the principal owners of towers are getting much more educated now, but uh, it's important that they measure and establish a baseline before doing anything to the tower that would create a need to detune or to adjust detuning, say adding a lot of new equipment to it and so forth, because they own the problem. If the AM station is out of whack, which is not all that unusual with directionals today in some places, they inherit that because they can't show that when they started, the AM station was at a particular point of adjustment, say monitor points out and so forth. And if they can establish that, all that the detuning has to do is not make that condition any worse. But
Yeah.
they have to correct the condition. And we have had at least two situations over the years where carriers actually took towers down rather than get involved with that and then make the necessary measurements and put them back up and detune to those measurements. And an expensive process. Fortunately, with a monopole, it's getting a crane out and one thing and another, but still, it's a very tedious and expensive process. But as opposed to spending $100,000 to reproof a 6-tower array, it's justifiable.
Yeah. So one thing I noticed about that video, there was a monopole that is, a single steel structure shown, and you showed two skirt wires that are used for detuning the structure. Now, I'd seen most of the monopoles I'd seen had 3 wires on them. Tell me about how you choose the apparatus you're going to apply to a vertical structure like a tower to detune it. How do you pick what it's going to look like?
Well, actually, 3 is pretty standard with us.
Mm-hmm.
And in that case, the third one was just behind the bulk of the monopole. You just couldn't
I
see
just
it.
didn't see it. Okay. Yeah.
That one does have it. We have had some situations where, for various physical reasons, only one could be used or two. It may not be as effective, but sometimes for aesthetic reasons where there's a disguised tower, say a flagpole, they are willing to take the chance on getting the job done with one wire, just so it doesn't look weird.
Yeah. Okay. So can you help us understand? I've being an AM engineer myself in the past, I kind of get what this looks like. What are the wires and what is in the box and what are those things actually doing to the vertical structure electrically at the AM frequency that we're interested in? What's happening?
What you're doing is setting up a out of phase current on the tower, and the box has a tuning network in it, and that effectively cancels out the radiation. Now, we have some situations have one that's in process right now that two rather in process right now that actually have three levels of detuning. They're tall towers, and when you use, and we do use NEC modeling extensively to determine what configurations are required, you find that you cannot reduce the current to the desired level with one tuning network and one set of skirts. So, as I say, we have two towers which are probably in the 500-600 foot area that that are using three skirts to accomplish this that have just recently been built. And those are, by the way, they're being used also for cell towers, but they have been built for wide area public safety communication systems.
Okay, and those were close enough to an AM facility to cause problems.
Oh yeah, one of them is near a two-tower array. The other one's near a six-tower array. I'm sorry, that one I believe is a six-tower array, and they're obviously very tall in terms of a wavelength, and they're very efficient re-radiators.
So what's typically inside your tuning box? A coil and a vacuum capacitor, or what would we find in there?
Yeah, it has basically a coil, a vacuum capacitor. It has a toroid type detection loop, and it has some switching and so forth to go for test purposes between detuned, undetuned states, and in the case of some of these where the skirt is high up on the tower, it also has some other transformative elements to take care of the adjusting for the impedance of the long coax runs to the skirt.
Ah, okay. Now, when it's been a few years. When we're adjusting that tuning box, are we? Maybe it depends on the circuit, but are we typically tuning for a maximum amount of current shown or a minimum shown on whatever the meter is?
Basically, you're tuning for minimum current flow, but the way we typically establish that is by using near field measurements. You set up what we call a quadrature measurement, which is a precisely calibrated position that has the radiator of the AM station in a null of a field meter and has the tower in a maximum, and then one tunes for the minimum radiation. Now, in some circumstances where one can't do that because you don't have a point source or you don't have the location where you can put the meter, we do a very precise modeling of the tower, and we come up with the exact values to go in each of those legs. And though we set to those values, and that generally is effective at making the tower detune.
I just realized I've done what you first described there. You called it quadrature. I've put my field meter on a tripod and adjusted it to where I could was getting, like I said, I was getting trying to read. I had it maximally adjusted toward the broadcast station, and oh, I'm sorry, I had that nulled out. Had it. The hard part was reading it because it usually resulted in the meter being 90 degrees off of my eyesight. So I
Yeah.
had to get a mirror or bring somebody with me.
Well, we actually use some remote meters with the meter.
Oh, wouldn't
Put
that
it
be
on
nice?
put it on a tripod. Depending upon the precision needed, in some circumstances, actually survey in the offset, because one of the interesting problems is in a very close-in situation, you're finding your positions for measurement along an arc, not along a straight line. So
Yes, yeah.
sometimes you have to actually survey it with surveying instruments to get close enough to get reliable results.
And that's why you do this very well, and I just did it well enough. It worked, but barely. Hey, so thinking about, I drive by some towers that I know are detuned, and maybe Chris Tobin can chime in on this, but I drive by some that I know, hey, I detuned that tower. There's one in North Nashville. I detuned that tower 15, no, more than that, probably 22 years ago. And I'm wondering, is it still effective? Is it still detuned? Does it still matter? Yeah, the AM station involved is still on the air, and it's still a 6-tower array. How would a station owner or an engineer, a curious guy like me, know if it was still working?
Oh, that's a hard question to answer, because generally the detuning systems are under the control of the tower owner, the Crown Castle, American Tower, or the Verizon, whoever owns the tower and manages it, and they're generally not accessible, nor do they want people to access them beside the people that they've declared qualified to operate on their sites. So that's a hard one to do, other than if you see difficulties like monitor points going out and so forth, you might want to bring it to the attention of the carrier. It is not unusual for problems to arise. You've got basically a network of wires in an area that's being fairly intensively worked by tower crews and riggers, and frequent equipment changes and so forth. So one of the things that we spend a lot of our time on, our guys in the field, is replacing components and parts of detuning systems and coordinating tower crews for that, because these guys may be careful, but it's a little hard to save a system when it gets tangled in a antenna platform being raised up the tower, and the wind catches it, and one thing and another. So it's not unusual, but the carriers are getting much more attuned to the FCC requirement that these things be maintained. The FCC is very specific about that.
Hey, we're going to move in a few minutes to the question about AM co-location, where some of these problems go away, but other problems pop up. Chris Tobin, I'm sorry I've been hogging the conversation here. It's a conversation I'm thoroughly interested in, because I used to do some of this. What comments do you have, Chris, about AM detuning, and what's your experience?
Well, I've been involved in detuning towers, and mostly they've been always directional stations that we worked on. And to answer your question, Kirk, and to back up what Lawrence said, my experience has been with the cellular towers, and since we couldn't get access to the tuning skirts once a year just to check in on them, we would make notes on our monitor points and observe very carefully all the parameters on the directional array, and try and keep an eye on what was before the detuning took place and what was on during the time that it was detuned, to sort of track whether the components are failing, or, as you pointed out, an antenna platform knocks into the wires and all of a sudden things are out of whack. But it's I'll tell you, lately I've been working with a friend of mine in another engineering firm, and some of the detuning and the practices that have been involved, cellular guys have gotten much better. I mean, 10 years ago, you were lucky you could get them even to pay attention. Now, they're actually willing to listen and work with you. So it's been good.
That's good to hear. And Lawrence, it sounds like what you were saying, your experience is the same. The cellular companies are paying attention. They're not thinking of this as an afterthought, but when they're finding a site or doing some work at a site that's close to an AM system, they're already at least aware and concerned about this detuning.
Yeah, they are, and it shows you the amount of activity. We've got three field engineers on the loose throughout the country constantly, day in, day out, and detuning, co-location, and supporting some other activities of ours. But those are the fundaments of their particular charges.
Gotcha. Oh, one more question about detuning. Are you are field strength readings and running radials, is that still a big part of it, or is it more now in computer modeling, method of moments, or however you may do that? Is it more theoretical or still very much on the ground practical?
Well, there are some instances where you can use method of moments. You're supposed to use it where a station has had its proof of performance done using that mode. You still have to use field measurements where the station uses field measurements and monitor points. But one of the problems is in doing that, because the FCC method does not take into account a whole lot of things, you still are on the hook for liability. And what a lot of the carriers have come to realize is that a station has, I think it's 2 years after a tower is put up, to protest it if they can make a case. And so there's a continuing liability, and that sort of resets every time that a major change is made. So it's important that at least monitor points and some other data be accumulated before that these before measurements be made, so that the carrier knows what the state of the AM is, because particularly a lot of the smaller AMs don't have the continuous technical support that some of the larger ones can provide into the whole thing. We love to work cooperatively with the AMs, but there are a lot of AMs that don't have a clue. So the carrier has to protect themselves. There's a situation that comes to mind where a station was sold. The prior owner didn't particularly care, and the several tenants of the tower, all major carriers, they didn't care if they didn't care, but the new owner did, and the new owner brought suit against the tower company and I think three carriers, and ended up going home with about $100,000 each in settlement for what he considered destruction of his pattern. So it's real, this problem, and so we always advise our carrier clients to take very careful pains to document the situation, and we're always glad to work with the AMs to try to resolve any issues.
Hey, one more question about this. We talked earlier about how would a radio station engineer or owner know if a cell tower that had previously been detuned had fallen out of detuning and was now affecting his pattern. And of course, you take your monitor point readings, and those are the ones you take on a semi-regular basis. But is it possible, does anybody actually set up let's call it a monitor point reading for a given cell tower that has been detuned? So you pick a point when you know it's detuned, you take you see how much energy is coming off that tower right then, and then you can go back and repeat that if needed to measure what's coming off of that cell tower directly. Is that ever done?
Oh yeah, we've done that on many circumstances where we surveyed in a point and put a survey marker there. Yeah, those exist.
Okay, good, good. That seems better than the proxy method of, hey, my monitor points out why. It could be that cell tower, or it could be something else. Hey, you are watching, enjoying. I hope you're enjoying. I sure am. Episode number 277 of This Week in Radio Tech. I'm Kirk Harnack, along with Chris Tobin in New York City, and Lawrence Behr from Greenville, North Carolina, is with us with LBA Group. And we're going to be talking about AM co-location. This is where, if you're an AM station owner or an engineer for an AM station, you may be able to figure out a way to, your land might be pretty valuable and you can use it for AM and other stuff at the same time, but it could be a big undertaking. So we'll talk about that in just a few minutes. Our show is brought to you in part by the folks at Telos and the Telos Zip 1 IP audio codec. There it is on the screen right there at the website, telosalliance.com under the Telos heading. The Zip 1, what does it do? Does it stream? Well, not exactly. The Zip 1 it's an IP replacement for your good old-fashioned Zephyr. Remember the Zephyr? You'd hook up to an ISDN line. You'd get a long-distance phone company to cover your long-distance charges, and you'd make a phone call over ISDN. Well, the Zip 1 does the same thing, except it's making this call over the internet or over your private network or WAN. It works over any IP connection, whether that be Wi-Fi, point-to-point IP radios, maybe a corporate WAN that you have. And of course, it does work over the public internet. In fact, years ago, when Steve Church and I sat down in a hotel room to figure out we need to make an IP codec, and here's what it needs to do. We assumed that most folks would be using this over the public internet, and there would be congestion issues, and there would be latency that would vary, and there might be some packets that didn't make it from one end to the other. They'd be dropped. And we also wanted to figure out, how could we make an IP codec that the sports director, the play-by-play guy, the afternoon DJ could just take it out in the field, plug it in, hook it up to the internet, and have a built-in list of the places that he might want to call, like the studio or another station studio in their cluster. Or maybe you're providing a feed for yet another radio station, and they've got a Zip 1 at their studio. The point is, it'd be plain language dialing by directory, if you will. You didn't have to know the IP address, which, by the way, may be changing. They didn't have to know a port number to go through. They didn't even have to open up a port on the station's router. We could use what we call a rendezvous server. And actually, in our case, it's called the Zip server. Well, the Zip server automates all this. It makes it just automatic. You see the presence information. Hey, is Studio A's Zip 1 online or not? And then you just highlight it on the screen and punch dial, and it dials it. The Zip server helps communicate through what we call NAT traversal, traverses the firewall, and gets your unit connected to the unit at the studio. And usually it does this with a direct connection, a peer-to-peer connection. In other words, the Zip server will hand off the connection that it makes to a peer-to-peer, and then the Zip server backs out of the way. However, some firewalls may be particularly restrictive, and so the Zip server can actually handle the passage of your audio data for as long as you want to make the call. It's no problem at all for the Zip server to handle that if you need it to. So either way, whether you're getting through the firewall or not, the Zip server will make the audio go from end to end. Hey, contact closures are included if you need to, start the next spot break by pushing a button at the remote site, or send back tally signals from the studio to the talent out there, like, hey guys, it's time to shut up. You can do that over the Zip 1. And by the way, you do have two-way audio, and it's two-way stereo audio, which can be thoroughly split. So you can have two feeds. You can have an English language feed of the baseball game and a Spanish language feed of the baseball game if you want to. All kinds of possibilities. And codecs in the Zip 1 that go all the way down to, I think, 16 kilobits per second. Maybe it's 20 kilobits. Bottom line is, even on rough connections, you can still get audio through from end to end. Now, here's the other key: low latency. Because we know that, streaming, well, anybody can stream from one place to another, but do you really want 20, 30, 40 seconds of latency? I don't think so. So the Zip 1 typically gives you under 1 second of latency from end to end. It all depends on the codec that you're using, how much buffering you have dialed in, and what the internet conditions are like. But typically on most connections, you get less than 1 second. And that means, in fact, typically you get down in the area of 200 250 milliseconds or so. And I've tested that right here at my office. So you can do a live talk show. You can do a sports show where you're talking back and forth, people at the studio or callers, and it all works out great. Check it out online at the Telos website. Go to telosalliance.com and look for IP codecs, and you'll see the Zip one. Also, when you go to that page, you'll see videos available. That's a couple of them are me showing you how to hook up the Zip One, how to make it work, and just what it can do for you. Thanks to Telos for sponsoring This Week in Radio Tech. All right, we're here with Chris Tobin. Chris, looks like it got dark there in New York City, didn't it?
Yes, it did. And my other CFL light just went out. I'm down to 1 instead of 2.
Oh, well, we can still see you great.
Yeah. I just quickly put together a little piece of white paper behind this to create a reflector, and I was just grabbing my Radman for a later discussion.
What? Oh, good. What do the neighbors across the street think of you standing on your porch? And,
I don't know. There have been occasions where I look across, and yes, there are apartments that I can see in very clearly, and they can see me, and I'm just assuming they figure, oh, it's a TV guy. So I got the little see, I got the little tube here, so people see that, they go, oh, look, it's a TV guy. Who knows? That's the great thing about today. You could do video and be anywhere, and people just go, oh, okay. And plus it's New York City. Nobody really pays attention.
Yeah, well, there you go. You got that too. Hey, well, Chris, our next topic with Lawrence, and please jump in whenever you like, is talking about actual co-location. Now, back when I was doing some of this work, co-location meant when several carriers were on the same cell tower. But we're talking about a different kind of co-location with Lawrence Behr here, our guest. Lawrence is going to tell us about co-location when the cell companies jump on the AM tower, maybe the existing AM tower, or maybe, you know what, guys? Let's do this right. Let's build a brand new tower. We'll fix it so AM will work from this tower, and we'll also make this tower big enough, strong enough to hold up, 4 different cell carriers' equipment on it. So, Lawrence, I want to hear about this topic of maybe charging the cell carriers some rent money. Tell me about it.
Well, I think most AM stations are very interested these days in how to make a little extra coin. And one of the areas that's been largely overlooked has been co-locating on AM transmission towers. And part of the problem has been a difficulty in effective ways of doing it. Secondly, the most AM operators are spot sales oriented. They're not really oriented to how they can make money off their infrastructure. So that's where this comes in. This is an opportunity for basically an AM station to turn their tower over to a cell carrier, tower company like American Tower, and continue to use it, but get revenue off the tower or the location, and I'll go into that more later, at a pretty good rate. It's not unusual to get $2,000 to $4,000 a month for a location. And very often the maintenance of the tower and a lot of improvements come with it at no cost as well.
I'm sure there's a lot of different ways to do this, but tell me a little bit about the business angle. Is it typically the case that the AM station owner, let's presume that the AM station owns the land and owns the towers and owns the copper under the ground and all that, and they I own an AM station in Greenville, Mississippi, where we have a 3-tower directional array. We've actually cut it down to 1 tower. And we're operating non-directional now. It serves our needs fine, and it simplified things a lot. But you know what? It's in a place that might be a great place for a cell tower. It's in the middle of a neighborhood that grew up around the AM tower site. How many times have you heard that before? And so, from a business perspective, is it typical that the radio station becomes the landlord, or does the radio station maybe say, you know what, American Tower or Crown Castle, tell you what, you just come in and you handle everything? What happens typically?
Well, I think the station very often remains the owner, and they are the landlord. But as a practical matter, the tower is under the control of the cell side of the equation. In effect, the AM becomes a tenant on it, and the reason for that is that very, very few AM stations understand anything about the requirements of the cell carriers, which are quite rigorous. And so it really doesn't work for most AM stations to take on that responsibility. And usually they would have to make a significant capital investment in improving the ground area. I don't mean electrical ground, but the site and getting the necessary improvements into the site and so forth to support the cellular operation. So, in most cases, they're just simply leasing to the carrier.
Got you. Got you. You know, now might be a good time to look at that other video that you produced. You did such a nice job on the first video we saw, explaining very concisely what to look for. So why don't we look at this other one? Can a hot AM tower be a cell site? Let's go ahead and watch that.
Thousands of AM towers are candidates for co-location of cell antennas. This can benefit both AM broadcasters and cell carriers. Visit the eye-popping co-location site that one broadcaster built. Some 20 years ago, early in the cellular era, a visionary WXGM engaged LBA to assist it in converting its single AM tower to support a new 800 megahertz cellular installation. This was successful, and more quickly followed. Space on the WXGM tower was soon exhausted, and 2 more towers were built on the same site. They were detuned to be in harmony with the WXGM tower. Thus, the creative use of AM co-location and detuning technology has permitted the intensive development of the WXGM site. In this drone's eye view, the WXGM AM/FM tower is to the left, an American tower monopole to the right, and a Crown Castle tower in the center. All towers are close, within a 100-foot circle, without interference, and in full compliance with FCC rules. Here you can see the LBA detuning systems on the Celco towers and the Colopole system on the WXGM tower. If you encounter a tower and need assistance in identifying its AM colocation status or in the design of an AM colocation site, call us at 252-757-0279. The service is free. Check out www.lbagroup.com for much more on AM colocation.
You know, Lawrence, the first question that comes to my mind is, I'm an AM station owner, and I mentioned already that we have a site in a residential area in Greenville, Mississippi. How would we determine if our site might even be desired by one or more cell companies?
Well, one way we help that process is we have an app on our website that is used by hundreds and hundreds of site acquisition people and cell company people. And one of the options on there is to put in a set of coordinates where the general area is they desire to have a new tower, and it will tell them whether there are AM towers available within a reasonable distance of that site, so they can then go and make contact with the owners and so forth. It's kind of a top-down process because the cell companies have requirements that come up for fill-in coverage and so forth, and they send this out to a huge network of site finders, site acquisition people. And they're the guys who go out, drive the roads, and look. And that brings up one effective means of reaching them, which is to put a sign, big, sign up there so that can plainly be seen from the road. This site or this tower is available for lease. And it won't be long before one of them drives by. If they have an interest in that area and they're scouting that area out, they'll check it out, and more they're getting over an aversion to this because, as you point out, so many of these towers are in suburban areas that have grown up over the years. They used to be rural, and now these towers have become fixtures of an area where it's very hard often for the carrier to get permission to build In most places, not all, but most, the zoning and permitting processes are much, much easier, even if it's upgrading an existing tower on an AM, than it would be to go out and start, as they say, a greenfield site, start from scratch.
That's such a big issue, and Chris, I'd be curious to hear what you have to say about in the New York City area. I'm sure it's a little bit different than Greenville, Mississippi. But Lawrence, like you have, I have sat in on city council and planning zoning meetings where a cell tower a company wanted to put a tower up, and all the residents, all the NIMBYs come out and say, no, not in my backyard. I don't want my children exposed to dangerous radiation and so forth. Never mind that. Well, anyway, and by going on an existing tower or by upgrading a site, a lot of that can be that hassle, that paperwork, that approval process can be either done away with or at least minimized greatly, as opposed to a greenfield site.
Yeah, they're comfortable. They feel comfortable with the tower they've seen over there for the last 20 or 30 or 40 years or more. And so you bring a real advantage to the table in terms of time to market for the cell people, and they're anxious to get something going very quickly, and having to go through a year of public debate and so forth just to get the chance to put a new 150-foot tower up, compared to maybe 2 or 3 months to get active with an AM tower. That's pretty attractive.
Chris, I guess in New York City, on Manhattan there, they don't build a new tower. They slap some antennas on the penthouse of a tall building, don't they?
Well, here in Manhattan, yes. Actually, right across from me are 3 carriers on top of a building. They just finished installing the new LTE transmitters, because I could look at them. They look like the new Alcatels and the Siemens, not Siemens, the other one. And out in the Meadowlands where the AM stations are, the amount of zoning and what goes on out there, probably not worth the trouble to try even considering co-location. They're just better off looking for buildings nearby and do it that way. It's tough. Yeah, it's tough because around here things are just pretty much maxed out. There's no wiggle room.
I might say that that where things are dense, towers are not as important as they are in the suburban areas and so forth. Rooftops are dominant, not so much towers.
Right, and here and then with cell sites, I think it's 100 feet or 150 foot is the window that they operate with, so the height-wise. So here in the city, most of the antennas you see are on the lower buildings, not at the very top high skyscrapers. Because in order to make the cell sites work as cells, you got to keep them at levels, at heights that you can control and beam forming of the signals.
Well, Chris, that's true. It's interesting, though, that we went through a process with one of the major carriers in Washington, D.C., engineering some 50 or 60 sites, and they didn't want any of them on a rooftop above 4 stories. So they had a particular fill-in technique that they were pursuing. So every place is a little different.
Yes, actually, I did read about something similar to that, and just up the block from where I'm at, Sprint put in a site, and it literally is at the 4-story level. They mounted on the outside of the building, 4 stories up, and I had a chance to talk to one of the installers, and he just said, this is what the engineers came up with. It works out. It fills the site. We're done. I'm like, oh, interesting. So, yeah, you're absolutely right. And with the newer technologies and the way they can do all these fill-in techniques, it's very interesting. The articles I've read from a couple of the different trades, it's fascinating.
I have to tell you that one of those sites, our engineers dearly loved it because the only access to the site was to go up through the go-go lounge.
That's great. I like that. That's a good one. I'm here on official business. Your cell phone may not work. I don't.
Wow. Chris, thank you. You answered a question that I was going to ask, and that is, do you ever find that buildings are too tall for an ideal site, and so you end up slapping the antennas on the outside of the building, not near, just 4, 5, 6 stories up? And you answered yes, you do. I guess they end up painting over or getting the antennas colored to be kind of invisible with the building. Yeah.
Oh yeah, there's one on the avenue on the east side, about 3 blocks from here. Every time I walk past to the store, you look up and you think it's brick, and it's protruding from the face of the building, and they're antennas. They're sector antennas. They're vertical. They're about 3 feet tall, 1 foot wide, and they've painted or whatever they do to the polymer on the outside, and it looks like brick face. And if it wasn't for the fact I know what coax connector looks like, or didn't connect, I'm like, oh, I know what that is. And that's it. It just, people walk past it every day, and it's about 3 stories high, up 3 stories high.
Yeah.
Yeah, there's a big deal in the cell industry for stealth sites. There's a whole segment that's devoted to turning things out that look like building faces, look like church steeples, that fit cell antennas into service station signs and billboards.
There's a place. Yeah, there's a place that I go past once a week. It's a flagpole, and I noticed the flagpole is very, how would you say, had a lot of girth to the vertical portion of it. Yeah. Like, okay, I've seen flagpoles before. This seems strange. And I look at the base, just off to the side, there's about, 5 or 6 of those outdoor cabinets. I'm like, oh, look at that. And there's an ice bridge. Yep, I know what's in that flagpole.
Yeah.
And there's a flag flying on the pole too. It's totally stealth. Oh, yeah. It's great.
We got one of those at a big private school just up the road from us here. It's a very girthy flagpole that with buildings at the bottom. Hey, Lawrence, a little conundrum passed my mind. I know that a number of churches with good-sized steeples have, sure, yeah, pay us and you can put your antennas up there. Do you ever have a situation where the supporting structure is not metal, but it's some other non-conductive construction, and you run coaxes up this non-metal infrastructure and antennas in a location where you need to detune it? Now, how would you detune an apparatus where the support structure was not metal? Do you ever have that?
Oh yeah, that happens. That happens quite often. Very often, it'll be, for instance, a utility transmission pole that may be concrete or polymer of some sort with steel reinforcing rods in it. And one way to do that, it could be a wood pole. You get some tall laminate wood poles, and you simply put a detuning skirt on it, and then you make sure that your lines are all stable, and you're basically detuning the lines is what you're doing. And if there's a reinforcing structure, you want to tie that structure in, if it's possible, to the overall system.
How tough is it to detune one of those big, fat, 6 or 8-legged water towers?
Well, it's an individual situation. You basically do an NEC model to determine what the critical points are, and you may use 3 wires, you may use 6. A lot has to do with where one attaches and can attach. There are a lot of restrictions on that. It's challenging, but it can be done. We've done a number of them, and sometimes it just can't be done. And we know of one circumstance where a utility built a water tower near a 3-tower AM, and they ended up at the end of the day, several years in a lawsuit later, buying the AM station and taking it off the air.
Wow. Yeah, I worked in Memphis on a 6-tower AM nighttime only location with a water tower and a television tower, and nobody could seem to get them detuned. You might have been. I don't know if you were called in, but they kind of gave up, and I think they end up having some relaxed parameters on the AM. But anyway,
well, we did have a situation where we're working with one of the major tower water tower construction outfits, and they were concerned about locating one near WHAS 50 kilowatt in Louisville, and it wasn't so much a detuning matter as an RF safety and construction safety matter, and they were looking at very serious. They were close enough to have very serious contact current problems and so forth, and they actually ended up revising the water system design and moving the tank to a location a mile or two further away because it simply wasn't economical or worth the risk to put it where they were going to put it.
Interesting. Wow. Guys, we're approaching the end of being on the air for an hour here, and this has been really fascinating, but there's so much we haven't gotten to yet. I'm going to ask both of you if during our commercial break coming up here in just a second, if you would think of a tip that you'd like to pass along to our listeners and viewers, that would be just awesome. Chris, maybe you did something cool this week that you'd learned something or like to pass along, and we'll get that as a closing message on our show. This Week in Radio Tech, episode number 277, Lawrence Behr is with us. He's with founder of the LBA Group, and also, of course, Chris Tobin is with us from New York City. Our show is brought to you in part by the folks at Axia. And one of the Axia consoles, I got to see, about 5 of these yesterday. I think it was 5, in Columbia, South Carolina. And that is the IQ console from Axia. Now, the IQ, it's very similar to the Radius console, but the IQ is designed to be expanded. So you could start with an 8-fader console, and you can add another 8-fader module, or you can add a 6-fader module that also has a telephone controller. They also have a 6-fader module that has some dedicated buttons for control. If you need some push buttons to do various functions around the facility, you can use that too. Bottom line is you can have up to a 24-fader console with the IQ, if you like. Now, the IQ uses the larger of the mixing engines that Axia makes for this line. It's called the Core 32. Now, that's spelled QOR, the Core 32. And if you go to telosalliance.com and have a look at the Axia IQ console, you can see pictures showing different configurations that the console can be put in, just as examples. Like I said, the 8-fader is with the monitor control. That's the main configuration. Then you can add side cars to it if you like, expansion modules. The IQ console uses all OLED displays, and these are bright and crystal clear, just really beautiful. You can see them from across the room. Your meters, your time of day clock, and your up timer, those are all OLEDs, as are every single fader has a status display that's on OLED as well. And that shows you what source is active on that fader. It shows you if you're talking back to it. It gives you a confidence level meter as well on each one. And a little menu is available on each of those OLEDs. So very cool, very compact, very easy to hook together. You simply run one cable between the IQ Surface and the Core 32 mixing engine. Now, the Core 32, this is really cool. Of course, it has local inputs and outputs, 4 mic inputs. It's got about 20 line level inputs and outputs. It's got some AES digital inputs and outputs. Of course, it has Axia Livewire Plus built into it. And here's what's really cool. It has a built-in Ethernet switch. You don't have to go buy a separate Ethernet switch and configure it. It's already configured to handle not only regular data, just browsing, whatever an Ethernet switch would do for you, but it is specially configured to properly handle live wire streams. So you don't have to configure anything. You just we'll give it an IP address, of course, do that. But then after that, just plug stuff into it. 4 of the ports on the Ethernet switch provide power over Ethernet. And that means that you can just plug, for example, one of Telos's phones into it. I've got one back here on top of this rack, and it runs power over Ethernet. You can even plug one of Axia's X nodes into it and run that power over Ethernet. So very convenient to hook up, very convenient to hook these together to other consoles or to a central core switch. Go to the website at telosalliance.com. Go to Axia and look for the Axia IQ audio console. It is very affordable and so sophisticated. I love it. I absolutely love it. Thanks, Axia, for sponsoring This Week in Radio Tech. Alrighty, let's check in with Lawrence. Have you got a tip you can pass along to all of our engineers listening?
Yeah, one of the things that's difficult today for many engineers because they're involved in other modes than traditional RF, but yet have those responsibilities on their job description, is to learn about that. And I would suggest that they might like to take a look at our website at lbagroup.com in our blog subsite, because we have literally dozens, hundreds of blogs and other informative informations. A lot of it having to do, yeah, thanks. A lot of it having to do with RF, with detuning, with AM colocation, and so forth. And so I just offer that up as an opportunity for people who don't have that chance often to educate themselves. And of course, if you have any questions, contact us here. We'd be glad to talk to you.
That is so cool. That is a real service to people who are your customers or not your customers or not yet your customers, is to give them information on how to do things, what to look for. That is, I'll spend some time on that. That's great. And we'll put that in the show notes as well, so folks can get referred back to, we'll also put in the show notes links to the 2 videos that we showed during the program.
Thanks.
Thanks, Lawrence. That's very helpful. All right, Chris Tobin, how about you? What's your tip of the week?
Well, the tip this week, since I was doing some work last weekend on a rooftop for an FM station for their tower, it was a low rooftop. There were 3 cell sites up there. So what I do now when I'm working in high RF areas, I bring my Radman. So since Lawrence was talking about learning about RF and things, this is something you should look up. I have been involved in more operations or projects that have put me within, I don't know, probably 10, 15 feet of cell sites, transmitter, emitters, whatever you want to call it. So this little guy has been very handy and has helped me out on, and they've been FM sites that I've been at, including rooftops of buildings sort of like Fort Times Square, Empire State Building, and a few other places. So something to consider if you're if you're an engineer that works at a site with a lot of RF, you might want to consider one of these. And you just wear it on your person, and there's an absorber inside the cap, so your body doesn't detune, so to speak, the unit. And you can also sniff out RF leaks with the E and H fields. Those you can look up and read about too. So that's my tip for this week, because I happen to be doing it 2 weekends in a row.
Nice. That's made by Narda. I did a
Yes.
couple projects where I wore what we called a Narda meter. So this is by Narda, and it's called the Radman. I see on the website they show the Radman XT.
Yeah. There's other various versions. This is the older one. It still works. It's just recently calibrated, so I'm good for the next year. I forget how this works, but yeah.
Nice. Lawrence, you've probably been exposed to so much RF it doesn't matter anymore.
I'm well cooked. Indeed, I am. But I might note that one of our LBA companies, LBA University, is probably the largest provider of RF safety training in the country. We've trained thousands and thousands of people in the cellular industry and certified them, and also we're a very big distributor of a couple of kinds of RF monitors.
I
The
see
RF
on your
safety
website
courses
too.
are important.
I'm sorry, Chris. Go ahead.
Oh, sorry about that. No, I take the RF safety course from other companies every year, just so I can go to rooftops and work and show them and say, look, I'm okay. And I get more access that way than other friends of mine who are also engineers that work at the same places and say, well, sorry, rooftop manager won't let you up because you don't have the safety training. So it's something to consider.
Good deal.
Yeah, that's
Guys,
very important. Yeah.
We better go.
Yeah.
I'm sorry. We got a delay there. Lawrence, go ahead and finish what you were saying about.
Oh no, I was just going to reinforce what Chris was saying, is that many rooftops and many carrier sites, tower company sites, won't permit you on the site unless you have RF awareness certification and unless you have a monitor.
Good to know. There's places I can't go until I get the safety training in the monitor. I also noticed that on the LBA site, under safety, under RF shielding, they have Faraday cages. So if you want to keep your pet Faraday in a cage, you can safely do it.
Yeah, we don't have any Faradays, but we do have the cages for them.
You'll have to.
Well, Kirk,
find
you're
those
in a cage last week, were you not?
Where what? Oh yeah, I was in a Faraday cage last week at WSB
Yes.
in Atlanta. Yes,
A lot of critters in that cage.
there were. The door was left open though, so the critters were moving in and out. Guys, it has been a blast. Lawrence, thank you so much for joining us. I appreciate you taking a couple hours of your time today to chat with me and to be on the show.
Well, thank you very much for the invitation, and I really appreciate the opportunity. And it's a great show, and I look forward to taking a look in on it from time to time.
Well, we'll and we'll post the show within a day or two, and so I put that always on my Facebook feed, and I'll be glad to send you an email and let you know when it's posted, so you can tell your friends. Chris Tobin, thank you for being with us. I appreciate you taking an hour and a half out of your day to be here too.
Yeah, no problem. I have a great time, and I've worked with Lawrence's people over the years with radio stations I've worked for, and great people, great stuff, and a lot to learn. And nowadays, RF is becoming a thing of the past for some. So anyone interested in learning about it, definitely check out the site.
You're right. It seems like fewer engineers are are well schooled in it, and yet there's more RF now than ever before. It's just everywhere.
Yeah, yeah. Well, a friend of mine, his engineering company, the reason he calls me up, he's like, I'm one of the few people he knows left that tinkers with RF stuff. And I've done some crazy things with wireless gear. And he's like, all right, you know what? You still understand the principles? Here's a couple of contracts. Let's go. But it's difficult to find people. I'm sure Lawrence knows that too. It's one thing to learn it by reading. And it's another thing to learn it and understand it when you're actually applying or being practically and getting the infamous RF burn on your finger or your kneecap or, things like that.
Yeah. All right, guys, thanks again. And our show's been brought to you by the folks at Lavo and the Lavo Crystal Clear console, by the Telos Zip 1, the best IP way to hear from there, and also by Axia and the Axia IQ, audio over IP audio console. Thanks so much to Andrew Zarian for founding the GFQ network, where we and other fine podcasts live and hang out. And thanks so much to Suncast for producing amazingly, by the magic of remote control, this episode of This Week in Radio Tech. I really appreciate you, Suncast. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.